What's different about this question compared to what we did yesterday? Emma? Very nice. Do you hear that? Neither of them have an isolated variable. What do we mean by that? The questions yesterday all started with either y equals, and that learning goal that we just did, y equals something, or x equals something. Notice that this one doesn't. So if you remember yesterday, I said every question we got to skip step number 1. Right? But today we're adding it in. So if it's not already isolated, we have to decide which of them we're isolating for. And if we look carefully, okay, for this question, it's kind of obvious, I think, but it's not always as obvious. I could solve for that, or that. But one of them is kind of the right choice to make in this case. Ryan, which one do you think? The top one, and which one, X or Y? How many people were thinking the same thing? That's a good gut feeling. And we'll talk about this maybe in a later one, but see how this is just one Y, it's just Y. So it makes it very easy to solve for. So we're going to do the same thing where we name them. Okay, and I'm going to do this. I'm going to say from 1. And you don't have to do this part, but I'm going to rewrite the equation. So if you can rearrange without rewriting, then that's fine to do. Okay, and what am I going to do to solve for y? Like, this is something we've already done. We've done it before. It's basically the same as putting it in y equals mx plus b, which is something we've done. So, Jill, what am I going to do? Nice. So subtract 3x and subtract 3x. And those are going to be 0. And I'm left with y equals, I don't have to write it in mx plus b form, but I imagine a lot of people will feel comfortable, most comfortable doing that. So negative 3x plus 10. It was positive 10, so it's plus 10. So negative 3x plus 10. Is that good? And now it's like a question from yesterday. It's exactly the same, but we're going to call this equation 3. And I just continue this question as if it were like the ones we did yesterday. So again, if you got yesterday, today's that one extra little step. Gets a little bit more complicated. You'll see in the third example, but what would happen if I sub this into equation 1? I'll give you a hint. That would be wrong if I did that. But why would that be wrong? Why would you say that? Very good. Anybody want to add to that? If I took 3 and subbed it into equation 1, what am I doing? I did rearrange it. That's what we started with. Like these, and when you rearrange, yeah, go ahead. Yeah, you're putting the equation back into itself. We're trying to find where 2 lines meet. So if I use the same line, I'm not going to find where these 2 lines meet. If I sub 3 into 1, I'm ignoring 2. Does that make sense? Keep in mind, but this only makes sense if you remember that these are 2 different lines that cross somewhere, and we're trying to find where they cross. So I have to sub one of them into the other. But in its original form, I can't sub equation 1 into 2. So I rearrange it, but this is like equation 1, right? 3 came from 1. So I can't sub it back into 1. Can't sub it back into itself. You got to sub into the other thing. So we're going to sub 3. And you can go ahead and try to continue. We're going to sub it into 2. And what would that look like? I'll remind you, negative 2x plus 3. So this is what I'm subbing. It's equal to y, which means I'm replacing y in equation 2. So I replace y with the empty brackets, and I put that inside, negative 3x plus 10. So go ahead, you can try to solve that if you like. A few of the questions today have some bigger numbers, and a lot of people found in the period before this that they were just missing a negative here or there. And when they missed a negative, the whole question didn't work out. But otherwise, their steps were bang on. So I really encourage you to remember that if you're doing the steps correctly, the substitution part correctly, and you know how to distribute, you know how to rearrange, and then instead of 3 times negative 3 is negative 9, you put 6, the answer's not going to work out. But that's like a minor mistake compared to this is some serious math that we're doing here, right? This is kind of some pretty big stuff. And if you're getting those steps correct and just getting the negatives wrong, or negative 3 minus 30, and a lot of people would say 27, because 30 minus 3 is 27. Okay, and then all year I've been saying, if you are inclined to make those mistakes, if you notice you're getting the steps right, but you're making those little mechanical errors, oh my goodness, get your calculator and just use your calculator. Negative 3 minus 30 equals, and then you'll be good. Okay, so finish this one up. Divide by negative 11. And so then x equals negative 33 divided by negative 11 is 3. Call that equation 4. And now I can sub that into either of the original two. A lot of people would want to sub it into equation 3 because it's kind of set up nicely for that. But you have to sub it into one of the original two equations. That's our rule. So I'll sub 4 into 1, and I get 3x, 3x plus y equals 10. But what is x? X is 3. So 9 plus y equals 10. Subtract 9, subtract 9. Y equals 1. It's all right? Any questions about that? Okay, example 2, take a look. It's a little bit different. Remember, you've got 4 options. See, some people are going to get caught in the habit that they always think they solve for y because earlier we were always solving for y. Why were we always solving for y before in the course? Nice. Because we're doing y equals mx plus b, which allows us to graph nicely, gives us the slope, all that good stuff. But that's not what we're doing here. So there's no rule that you have to solve for y. And in fact, don't write this down, but just watch. Imagine I tried to solve for y in equation number 1. So I'll number these 1 and 2. And imagine I tried to solve, so from 1, if I solve for y, I'm going to get negative 2y equals subtract x from both sides, negative x plus 4, and then divide by negative 2, divide by negative 2, divide by negative 2, y equals 1/2 x, oh dear, minus 2. So that should never happen. If you've done that, you've chosen the wrong variable to isolate. Okay, so I'm going to get rid of all this now. And I'm going to go back to the drawing board. Okay, and I'm going to think about, well, wait a minute. I've got 4 choices. 1, 2, 3, 4. Which one should I solve for? Which one won't give me fractions? X in... I could do x in the second one or the first one. Both will work, but the first one's positive. It's a little bit easier. So let's pick that one. So we're going to solve for x in the first one. And what would that look like? I'm going to add 2y to both sides. So I get 0 there. And you're left with x equals 2y plus 4 as equation 3. And remember, that came from 1, so what do I have to sub it into? So go ahead and try to do the substitution. And if you weren't doing it yesterday, something else that you can, like a goal you can set for yourself today is writing those instructions. You've not done math like this before. So then people think, oh, well, that's not really math. This is just like school stuff. No, this is like these little instructions are part of this process. So you do have to do them. So get used to naming them, 1, 2, 3, and describing what you do. You don't have to use the exact same words that I use, like from one, but it's kind of easiest to just do it that way instead of making up your own. So your first line should look like that. 3 came from 1, so we have to sub it into 2. And this is equal to x, so I'm subbing into x in 2. So look what I wrote, because this can be tricky. It's negative x minus 3y equals 1, right? Negative x minus 3y equals 1. And then I take x and I put it in those brackets. And then when I distribute, it's going to be like negative 1 times this and negative 1 times that. So negative 2y minus 4 minus 3y equals 1. And then I'm just going to solve this quickly. Plus 4, those give you 0. Negative 5y equals 5. And y equals negative 1 for this one. Somebody remind me, ultimately, what are we trying to do with this process? It really helps if you think about why and try to visualize and understand why you're doing what you're doing. Find the point of intersection. I've got 2 lines. Remember we did this yesterday where I graphed them with that software, right? So I've got 2 lines. I don't know exactly what those 2 lines look like, but imagine they look like this. Whoops, that's not going to work. Imagine they look like this. Imagine one goes like that and the other goes like that. There's their point of intersection. Point of intersection has an x and a y. I found y. What do I have to do next? Find x. So I would call, we're not going to do this because we've done this a bunch of times, so we're going to kind of skip to the next example, but I call that equation 4, and I go back up to one of the 2 original equations, 1 or 2, and I take 4 and sub it in there. I found y, now I need to find x. So I sub in for y, and then I find x. Any questions? One more example, and this one's a little bit trickier. But when we practice, there'll be some easier ones first, and then there'll be some trickier ones after. What's the first step that we started with these ones today, Michael? Rearrange. Right. We're trying to isolate one of the variables. What makes this one harder? Corbin, what do you think? What's different about this one? So remember in the example 2, or B, we looked at each one of the variables, there's 4 of them, and we looked for which one was the easiest to solve for. Corbin, go ahead. Each of them have a number in front of them. So again, for some of you at least, the next level of understanding of mathematics could come if you start doing things like this. This is something that, like when you start to really understand stuff, you're able to do this. So I'm not actually going to do any work, but I'm going to plan out the steps in my head. I'm going to think about what's going to happen. So imagine I solved for this x. Guys, listen for a minute. Imagine I was solving for this x. Guys, the first thing I'm going to do is I'm going to move the 2y over. And then I'm going to divide by 6. Can you, does that make sense? You visualize those steps? I don't know what the numbers will work out to. I'm not worried about the specifics. I'm just planning the general steps. I'm going to move 2y over to get 6x by itself. Then I'm going to have to divide by 6. Those would be the steps. What's going to happen when I divide by 6? Jill? Yeah? What else, though? Something bad's going to happen. Yeah, can you divide 2 by 6? I mean, you can, but not evenly. What about 10 divided by 6? That's going to be nasty too. Neither of those work. What if this one will be even more clear. What if I try to isolate that one? So what would I do? I'd move the 4x over and then divide by -7. What's 4 divided by -7? Not going to work. What's 10 divided by -7? Not going to work. Okay, so I'm not solving for that. I'm not solving for that. What if I solve for that? I'm going to divide by 4. What's 7 divided by 4? Still not going to, 1 point something. Still not going to work. What if I isolate for that? What am I going to divide by? I'm going to move the 6x and then divide by 2. 6 divided by 2, 10 divided by 2. Hey, that's going to work. See how you're planning out those steps, kind of looking ahead, thinking about what's going to make the most sense here. So if you pick the wrong one, you're going to get yourself into a world of trouble because you're going to get all kinds of fractions. It's going to be nasty. It's not going to work out. If you're getting decimals and rounding, you're not going to get the right answer. I'm going to tell you that right now. It's not how this process works. So part of the understanding is picking the right one, and it can be tricky. Okay, but most of them are not really, really hard. They're fairly straightforward. So 1, 2, and we're going to pick one from 1, and we're going to solve for y. So 6x plus 2y equals 10. Subtract 6x, subtract 6x. Go ahead and try that. See if you can get that finished. So I got y equals -3x plus 5. How many people got that? I moved the 6x by subtracting it, so that gives me 0. So I got -6x plus 10. You don't have to write it in this order. Some people do, some people don't. It's fine either way. -6x plus 10. And then what do? Divide by 2, because it's 2y. And look at how it all worked out, right? 6 divided by 2 is 3. 10 divided by 2 is 5. Like, it all worked out. That's why we picked that one when you look back. If I had tried any of the other variables, it would not have worked out nicely. Any questions? I'm going to stop there. You can finish that one if you want. I will put the whole solution up after. But I'm going to stop there and let you practice a few on your own. Because that's the new part of today, is getting this step. Then everything's the same as what we did yesterday. Questions? Sure?